Hello students, in last lecture we learned about different problems which was based on domain, range and codomain. Today we will learn about types of relation. So we already know what is relation. If R is a relation, then R is a relation from set A to B, then R will be subset of Cartesian product of A cross B. And we know R is a set also. Here the elements are pairwise and the first point is taken from set A, second point is taken from set B. And if it is set, and here it is written in set builder form, if it is set written in set builder form, it has subset also. So we know null set, which is subset of every set, and we know about universal set. When we are taking all the objects together and the set itself, then that set is called universal set. So students, these two sets together have one name, that is called trivial set. So we will see that empty relation connected with these trivial sets. We have two relations also. Empty relation, a relation R in a set A is called empty relation if no element of A is related to no element of A. That is R equal to 5, which is a subset of A cross A. That means we have to make such a set which will be a null set. So like here I have taken one set, and that is also a relation. This AB is taken from set A, and here A equal to 1, 2, 3, 4. 1, 2, 3, 4. So if you take any two numbers from this set and you want to find difference, like 2 minus 3 will be minus 1, but it never you will get 10. 4 minus 3 will be 1. 4 minus 4 will be 0. So never you will get difference equal to 10. So that means this set is a null set. And this, if it is a relation, if R is a subset of A cross A, then this relation is called null relation or empty relation. Similarly, go to universal relation. A relation R in a set A is called universal relation if each element of A is related to every element of A. That is R equal to A cross A. That means R, we know that this will be subset of A cross A. But when we got this type of thing, that R is equal with A cross A, that we have taken complete A cross A as a relation, that time it will be universal relation. So we can take one example also. If R is a relation such that A minus B mod value will be greater than equals to 0, where AB taken from set A and set A is 1, 2, 3, 4. So students, any number if you take 1, 2, you will get greater than equals to 0 because this will be 1. If you take 4 minus 4, it will be equal to 0. So greater than equals to 0, this condition satisfying every elements of the Cartesian product A cross A. Here Cartesian product of A cross A, what it will be? We already know that how do you find out Cartesian product of A cross A. Here elements will be 1, 1, 1, 2, 1, 3, 1, 4, then 2, 1, dot dot 2, 4. Similarly 3, 1, 3, 2, 3, 4, 4, 1, 4, 4. So you check any two these elements always will be greater than equals to 0. So student, next we will see what is there. One note I have written here, that these two relation together is called trivial relation. Then we will see ways of representing a relation. How we are representing relation: we are representing by set builder form, we are representing by roster form. In roster form, every elements will be written here. Then it is roster form. Sometimes we are writing in this way also, a related with b if a, some condition is there, a equal to b equal to a plus 1. You can see here roster method, set builder method, and this one is also expressed as a related to b if and only if b equal to a plus a. In note I have written that if we are telling a comma b, this pair is belongs to the relation R, so it means a is related to b. Here these two point is related with each other, and it is denoted by a r b. Then we will go to equivalence relation. Equivalence relation definition tells us a relation R in a set A is said to be an equivalence relation if R is reflexive, symmetric, and transitive. So now the question is, what is reflexive, what is symmetric, and transitive? So any relation in a set A is said to be an equivalence relation if these three property satisfied by that relation together. So first we have to inquire about reflexive relation. A relation R is called reflexive if called reflexive R in relation set A is called reflexive if A comma A belongs to R for every A belongs to A, and it's called symmetric if, that means what was there, both elements in the pair will be same, and here both, if a1 a2 is belongs, so we have to find out that its opposite elements are there or not, the pair of opposite elements are there or not. If it is present there, it means it is symmetric. A relation R in a set A is called reflexive if a comma A belongs to R for every A belongs to A, capital A. And it is called relation R is called symmetric if a1 a2 belongs to R implies that a2 a1 belongs to R for all a1 a2 belongs to A. And the relation R is called transitive if a1 a2 belongs to R and a2 a3 belongs to R. If these two are exist in the set and same time this element also exist, a1 a3, the first element of the first pair and second element of the second pair, if it is it's given in the set, then we will call it is a transitive relation. And if these three relation satisfied by any relation, then that relation is called equivalence relation. So another one type we have, that is called anti-symmetric relation. Let A be any set. Let A be any set. A relation on set A is said to be an anti-symmetric relation if A comma B belongs to R and B comma A belongs to R, which implies A equal to B. So students, don't mess up this one with the symmetric relation. In symmetric relation, they told us if AB belongs to R and it will implies BA belongs to R. This is symmetric. But In antisymmetric, it's telling us if AB belongs to R, BA also belongs to R, and which implies A equal to B, then it is called antisymmetric. Antisymmetric relation. So we will see example of reflexive relation. Suppose R is a relation on a set A, then what it will be? R will be subset of Cartesian product A cross A. So our relation is given like this, that 1 comma 1, 2 comma 2, 3 comma 3. So it is given in roster form, and our set is given 1, 2, 3. So students, we know that what are the element will be there in the what are the element will be there in A cross A. So 1 1 1 2 dot dot 1 3. Then 2 1 2 2. No, write down all the element 2 3 3 1 3 2 and 3 3. These elements are there, and we have seen these all the if our set is 1 2 3. So we know the definition that R is reflexive if A comma A belongs to R for all A belongs to A. So whatever A is there, 1 2 3 elements 1 2 3, and its points are also present, 1 1 2 2 3 3 points are present here. So we have taken from the across A, so it is reflexive. Now see the example 2, that R is a relation which tells us it's a symmetric. R is a relation in a set A, where A is set is A B C contain these elements, given by R equal to A comma B, B comma A comma C, C comma A. Here R is a symmetric relation. So why it is symmetric? Because we know the definition of symmetric relation. If AB belongs to R, it will imply BA also belongs to in R. So here you see A, B is there. So we have to find from the other elements that BA is there or not. So BA is there. If our AC is there, so we have to try to find out our CA is there or not. Or if you see from the last, so if CA is there, so we have to find out our AC is there or not. If we have BA, so we have to find out our AB is there or not. If this condition is satisfied, then we will say uh, this relation is symmetric relation. Similarly, transitive relation, a relation are on the set of natural numbers defined as like this, and this is the example of transitive relation. So students, we will see the example of transitive relation. Here it is telling that here x and y is related by this condition, where x is less than 4. So and xy are natural numbers. Xy are natural numbers. So x is less than 4 means what? X will be 1 2 3. Okay, and if you put here, if you write it in roster form, then it will be 1 1 comma 6, then 1 comma 2 comma 7, then 3 comma 8. So this element will be in the set relation, in this relation. Okay, now we have to check that the transitivity, what was the definition of transitivity relation? If AB belongs to R and BC belongs to R, then we have to find out that AC is also belongs to R or not. If it is belongs to R, then we can say R is a transitive relation. R is transitive. Okay, So here 1 comma 6 belongs to R and 6 comma is not belongs to R. So here 2 comma 7. So this will be transitive relation or not, that we have to check. Students, this one is the special case that if 1 comma 6 belongs to R but 6, the first element 6, like that element is not belongs to R. So again similarly 2 comma 7 is there, but we don't have any element like this where 7 is the first element in the pair, and similarly 3 comma 8 belongs to R, but we don't have 8 comma something belongs to R. So if this type of problem you found, then we will say this one is transitive relation, and you will remember the definition of transitive relation. Student, you will practice and remember these all definitions, and if you have any doubt you will message me in my personal WhatsApp message, and you will show me the homeworks also. Have a nice day. Thank you.